some Bize for us today, and we're looking at two theorems today. And the first one's perp from center to chord, and the second one line from center to midpoint of chord. So we're just going to look at these two and then apply them. So I'm going to work through the exercise, some of the questions, just see how we're going to get into them. Okay, so for this first one, we're given this. We're given that there's a line that's coming from the center and it's perpendicular, so at right angles to the chord. So the chord, remember, chords join a circle from one side, one part of the circumference to the other. So we're given this, and if we are given this, then we know that this must be true, that we've got the line being bisected. So in other words, let's highlight instead of all this pointing, right, and say, so we're given that we've got a line and it hits a chord at 90 degrees. If that's what we are given, then what we know is that that line bisects that. In other words, this part is equal to that part. Okay, so we're given that it's perpendicular, and from there we know that it bisects it, it cuts it in half, each line segment is equal. Okay, so that's the one, and the reason that our reason is perp from center to chord is because that's the bit we're given. We're given that it's perpendicular. Okay, then the second part is, let's say that we're given almost like the opposite. So in this case, we are given this, so we're given that there's a line coming from the center. You see it coming from the center there, and it's hitting the midpoint of that chord. So if we're given that, then we know that it must be at 90 degrees. So that's why our reason is what we're given, which is that there's a line that's coming from the center to the midpoint of this chord AB, and if we're given that, then it must be at 90 degrees as shown here. So in this case, we are, where's my pen? We're given this line from the center to the midpoint of this chord, and if that's what we're given, then we know that it must be at 90 degrees. Okay, so let's see how we would use this. How are we doing? We're feeling okay. Do we need some more music? But awkward when your answer's no. Okay, so we've got these are the questions I want you to please do from exercise 2. Question A. So we're going to just run through quickly how we get into these, and then you can actually do them and do all the formal writing down. So O is the center. Important bit. Given a center, and we're given a chord, and we're told that it's at 90 degrees. That's what it tells us here. So let's take this pen down a little bit and say, great stuff. We're given this, and we're given a chord, and we're given 90 degrees. And before long, you'll be going, okay, well, I know that, therefore, perp from center to chord is what I'm probably going to use. Given that's what that means. Remember, that sign there means 90 degrees, means perpendicular. Okay, so if you're given that, what do we know? Well, we know that this is cut in half. So if that whole thing's 8, you know what each of those is. If that's 3 and that's 4, and you're in a right angle triangle, whose theorem do you think you're going to use plenty in this? Yes, our dear old friend, Pythagoras. Okay, so then you can find out what BC is, what AB is, what OC is. You can solve everything. What's special about this line, by the way, OC? With regard to the circle, what's very special? What line is OC? Okay, OC is a radius, and we in circle geometry look for radii. Remember, one radius, many radii. Cool. Question B. We have got O as the center. Okay, a crucial bit of information because everything we're dealing with in this theorem is about being in the center. and it looks like we've got a chord that's been cut in half by this line that comes from the center. So we've got a line from the center to the midpoint of the chord. Yes, very much so. I'm reading this one up here. I'm reading this at the top to say, oh, we've got a line from the center to the midpoint of a chord. So what do we therefore know about this angle over here? Angle OBA must be 90 degrees. That's what our theorem tells us. If that whole thing's 16, hopefully you can work out what AB is if it's half of 16. Calculator, not necessary. But hey, why not? 16 over 2. Okay, so you've got that side, you've got this side. Whose theorem are we going to use to find out the third side of this right angle triangle? Okay, Pythagoras, Pythagoras. Here we're given an F, the second last question I want you to do. Yes, because this type of question comes up often, so you definitely need to practice on. We're given a line that is perpendicular, and it doesn't immediately look obvious what we should do because we've got two of these. Let's put it in nice different colors and say, well, we've got 90 degrees. What shape should we create so that we can use Pythagoras' theorem? I'm with you on building a triangle, so let's make a triangle. Remember, what's special about line OB? What's special about radii in a circle? Well, I think what's special about them is that they're all the same length, and that might come in handy. And our last one, well, if this distance is x and this is 8, maybe just a hint so that you can get into the question, because I'm not going to be there when I know that this question will come up. Well, presumably that whole length there is x plus 8. What's special about OE? What's also special about OA and OB? No, they're all radii. So radii, see how they're coming up? We've got a line from the center to the midpoint of a chord, therefore you know something about that angle. Therefore you're going to use our dear old friend's theorem that we love so much in 90-degree triangles. And I think it's time to end off with some... Where's that? That was less dramatic than there. Oh, it's coming up quite often. Oh, I don't know. Is it... Whoa. Okay, I think that's enough of that.